Hello, my name is Jeffrey Wade, and as this says right here, this is the AwsMPI Homework 3 screen capture. Okay, it's 1:48 in the morning. I've actually been working on this for about 6 hours, and there's many reasons why it's taken me so long. This is my fourth screen capture and video uh, log um, with open broadcast software. Okay, and if you watched the other two or watched one of the other ones, you can tell this is a different desktop environment. Although this is Ubuntu, this is uh, the LXD desktop environment. I created a user account, um, GWade at the 1000, 1001 user ID and G group ID. Okay, and I initially did this to test processes on my to see how much CPU consumption was being used with the open broadcast software. So that's the reason why I just decided to install the um, LXDE desktop environment. Plus, it's got some eye candy to it. You gotta admit it is very attractive. So but it took me a while. I was testing my mic, and one thing I didn't do. This is actually going to be about to be my fourth video post to YouTube. Uh, if there's any users who watch this besides who this is intended for, you will understand that the open broadcast software has been using like 85-90% of my CPU, like max CPU capacity, and um, I have got another system with OpenBox on it, and I've had that system for a couple years. I've done all kinds of things with that system. I've installed Oracle 11G Enterprise Edition. I've run clusters on it. I've had hybrid stacks on it. I've ran my own cloud server on it, connecting to another cloud operating system box and being able to connect to that cloud. Um, here's actually a photo of not to get off topic from the nature of this assignment, but here is OpenBox, um, Echo Desktop Session OpenBox, uh, with Ubuntu 14.04 running. This is just recently running. This was when was this? Um, well, I can't see it. I don't have the dates in here. This is like last week on my desktop. I just got access to my desktop for the first time in over a year. It's been in storage, but I like OpenBox for a few different reasons. One, it does not use much of my CPU power. Okay, it's very light on my CPU. The way it handles, the way the window manager handles tasks, is very convenient. I've configured OpenBox a bunch of different ways with FB panel, GNOME panel, Razer QT, and now LXDE, which I've done LXDE before on Debian, Ubuntu, and FreeBSD, but that's not the point of it. The point of the matter is that OpenBox uses less CPU, has less CPU consumption generally speaking, and I wanted to see if that was the case using the Open Broadcast software. Okay, so once I got started and I was also testing a script that I have written. I should tell you that I've also been testing a Python script I've coded to automate the upgrade, update, and installation of all the software needed, as well as the git clone of the repository where the benchmark executable and the quickbench.sh bash script reside. Okay, and this program that I've written is gonna automate the complete installation, the update, upgrade, distribution upgrade of our kernel, the installation of all the packages we need, build essentials, G++, the MPI libraries, a few security packages, in order to run and actually do the process testing. All right, but this script also is just going to just run straight through it, take us from a fresh install basically is what we're about to do, and then um, test the amount of processes running across our cores and print that information out to a text file. All right. But to illustrate to reiterate and illustrate the difference between, if you've seen the other videos that I've put up, the temperature is about 20 degrees Celsius, or almost 40 degrees per unit core on our processes, and our CPU consumption says like 40% using this desktop configuration. Okay, now I've created a plus I also like OpenBox because I can move around and perform a lot of tasks and open a lot of windows via setting keyboard shortcuts within config OpenBox in the rc.xml file, which I have done. I've got two terminals. I have access to. I can do an LX terminal with control alternate T, or I've set the control alternate G for the GNOME terminal. I'm a fan of the GNOME terminal. So, with that said, I'm going to actually close this window and close this. Oops. In my last video log, I had an extreme amount of trouble with lag as well, and I was trying to do a tutorial on manually installing Eclipse C, C++ with the Oracle 11 or the Oracle JDK, and like it was just skipping scenes, it was skipping frames. My voice wasn't lagging, but the movements within the screen capture itself, the video, was dragging, was lagging, and I think that has to do something with TCP port 6 and the installation of the Eclipse OOMP, the OOMP installer, or the Eclipse installer by OOMP, OOMPH. Okay, so enough of that. What we're going to do here is, first off, we're going to log into my management console, and we're going to create an instance. Now, there's two ways haven't been informed. There's two ways you can do this, and I've actually ran into something kind of creepy here. I don't have any running instances. I have no volumes. I have no key pairs. And no, if this still will not let me delete this security group, something is very wrong here. And I got a network interface that has gone promiscuous. Yes, okay, it's allowing me to delete it now. I just had to log out. Okay, it wasn't letting me do that there for a second. There was like a hidden network interface for some reason. I don't know what was going on with that. But so I've ran many instances this evening. Okay, I got no running. I got one. Now it's showing I have one that's terminated. But I've ran many instances trying to get the script right that I'm fixing to execute to handle the automation of everything, and testing my mic volume. I was having a lot of trouble with my mic volume, and the audio input from my microphone working with OBS, and I figured out what it was. I put this volume applet, if you can see this right here, on the panel, and then went into volume control settings. This desktop environment doesn't use Unity settings, the Unity settings daemon, which is the standard desktop environment of Ubuntu, the default desktop environment. Okay, so I have gone into the Awesome Mixer, and you have to hit F4 in case this comes up for anybody who's willing to try this desktop environment or wants to try this desktop environment. You have to hit F4, and then under F4 you can scroll back and forth between internal mic boost. I increased the mic boost and the screen capture. Both were on 0. So I hope that you can hear me. If I'm talking too loud, you can turn yours down, but I cannot input mine up. I've watched 6 videos already this evening of where the volume just wasn't getting there. So I had to figure out how to do that, and I got it accomplished. But so it's been a few different things. Here's my EC2 dashboard. So it's taken me a while to get on the ball here, and I still have to walk 3 hours walk 3 miles to get back to my house across the bridge. So I need to get on the roll here. This shouldn't take more than 15 minutes though. I'm going to launch an instance, and there's 2 ways you can do this. You can launch, there's two ways you can calculate the scalability by measuring the processes across individual CPU cores. Okay, you can do it via multiple instances with going across nodes measuring one CPU, or you can do it, this is what's been brought to my attention, using what would be considered like one box and say a motherboard of like 36 CPUs, or one box with a motherboard of 9 quad cores, would be one way to look at it, which would yield 36 individual core processors. Okay, so we're going to choose option number 2, and we're going to install the Ubuntu Server 14.04 as our Amazon AMI image. Alright, and now we're going to choose the option of 36 cores with 60 gigabytes of RAM, 60 gigabytes of memory, and that is this image right. Have I passed it? Okay, sorry. This image right here. The compute optimized C4 times 8 extra large, 36 CPUs, and 60 gigabytes of memory, 60 gigabytes of RAM, and this is the EBS backed only. Now this is not part of the free tier, but we do not plan on using having this instance consume a lot of time or a lot of resources. Okay, we're going to run this, get the information we need, and delete the instance. All right. So hopefully they won't charge us. So we want one instance of 36 cores. We're going to add storage. Storage is fine. Next, create a tag. Next, configure the security group. Okay, we're going to configure the security group. We're going to make it my IP, and that's going to be the launch wizard. All right, now we're going to, your instance configuration is not eligible for the free tier. We already know that. I just explained that. That's okay. We're not going to use much of this instance, so hopefully it'll still be free. So I'm going to launch this instance, and it's going to ask me for my to create a key and pair for my .pm file. All right. I want to do a new key pair, and I am going to do. What am I going to name this thing? I'm going to call it Greyhound MPI AwsMPI HW3, and that's going to be the name of our key. So I'm downloading that. I'm going to launch this instance. Okay. Launching the instance. Fire away. And view the instance. And the instance is pending. Alright, while that thing pins, I'm going to do some administration here. I showed you what my home, I told you that I created this account for the sole purpose of testing this with OpenBox, the OBS software, and for doing this tutorial or video log. So if I haven't said that, that is. And I am using, in case you're wondering what operating system this is Ubuntu 14.04, and I am using the kernel version, if I haven't already told you, of 3.19051 generic. Okay? Now, I have got to move downloads, move this freshly downloaded security key to my home directory, which I'm about to do, and that is done. And we're going to change the permissions on that, which is a must, to .pm to 0400. Whoops, excuse me there, babe. If you don't mind, move back my cursor. Stats Greyhound AwsMPI 36 .pm. Okay, why did I mess that up? That is Aws, and this is MPI, and then it's 0400. All right. Exit this. And that was how's our instance looking? Our instance is up and running. So we're doing good here. We're doing well. Okay, that's what we like to see. All right. Now with our instance up and running, we are going to connect to our instance via SSH. Okay. Let's find out what our connect is. Oops. Take this off and put that on. Let's find out what the connect is here. Oh no, it's not. It is running, but it is not initialized yet. So we gotta wait for it to initialize. Wait for it to actually. It's basically it's cranking up here. So let me make sure this is right. I actually just tried to do a video, and the download, once I was connected to my instance, it was horrible. I was getting kilobytes per second, and I don't understand why. So I just killed that procedure and then deleted my instance and started over from scratch because it was terrible. Okay, so okay, yeah, that's right. And take my Bluetooth out. Make sure that would matter on my end, but it does out of security. Potential security breach. Start on dbus. Why is it doing that? I need to do this. And alright. Yes. Sudo break out some system D here. Stop. Cool. Alright. Just to make sure I don't have any chances of something getting crazy here. It's still initializing. Check out my dashboard. Go back to my running instance, and my instance is still initializing. Okay, well, we're gonna let it initialize, and that is what we're gonna have to do here. So, in the meantime, I'm gonna show you a script. Okay, I have designed and created. I've also tested this script. Many of my instances have come from testing this script. The update, upgrade, and distribution upgrade of our kernel and all our system software. Okay, followed by the installation of about 10 packages, and then the git clone of the MPI repository on GitHub that is going to allow us to test our threads, all right, and the amount of processes on our going across our cores, right? Right. So, I have written about a 60, 70 line program here that it's well documented too. I got good comments on it. Cat MPI install 1.py. Here we go. Here is this program. So this MPI install.py Python program is designed and created to automate the post-installation update, upgrade, and distribution upgrade of an Amazon AwsMPI AMI, and download, install the package dependencies to perform a control test of processes on 36 cores, 36 processors within the cloud. Okay, so what we're going to do first is this script. What it does is we create a list, and we're giving it the argument of we're creating some strings in the list that are going to be passed as arguments to the call function of the subprocess module. All right. So we are going to use sudo apt get update. Update to that apt get is the is Debian's, and well, since Ubuntu is a Debian-based operating system, Ubuntu's package management software. Okay, so it allows you to install, remove, and apt as the automated package automated advanced package. What does APT stand for? Advanced package, man, APT. Command line. Advanced package tool. There we go. Tool was what I was looking for. So it's the advanced package tool. And so APT is it can have many different arguments hyphenated with it. You can have get, you can have download, you can have source, you can have APT cache search. It has different arguments that APT can be passed, and then once its main argument, which is what it's hyphenated with, the main argument can be passed another argument, which would be update, install, download, whatever. So the first argument in our list is sudo apt get. The first command line statement, I should say, is sudo apt get update, followed by sudo apt get upgrade, followed by sudo apt get distribution upgrade. Now the distribution upgrade only is there just and solely for the purpose of upgrading the kernel version. Okay, I believe our Amazon instance is going to be at somewhere around 3.13074, and this distribution upgrade should take us to around 3.1308. All right, we're good. We're initialized. Okay. I'll get back to this in a minute. Oh, well, here, I'll finish out this list, and then from this list, we'll continue. Okay, so then you see this. Exit pipe, parentheses, the argument of the $1 pipe bash. All right, so I ran this before in the past without this, and I noticed that it was forcing me to exit my SSH instance after the sudo apt get distribution upgrade. Why it was doing that, I have no idea. But I guess it, I tried putting a sudo update db in there to update the local database. That wasn't working. So I had to get creative with a command line, with some type of statement to initialize the for the operating system to sort of initialize and represent what had happened, which was the update, the upgrade, and the distribution upgrade. And I've done that by giving it this, creating this argument here, which I'm kind of proud of this. But so basically, what this is that exit is piped to this parentheses here, and it's going to get caught in the argument as an argument. It's going to be stored in the $1. Okay, now once that happens, that's going to be piped to bash. So really, it's essentially like bash is opening. So I'm opening a sublevel shell, and then it's immediately that sublevel shell is getting past the statement of exit. Okay, so it immediately opens and closes the shell. All right, and then our local database on our cloud image our cloud operating system is going to be updated. All right, and then it's going to allow us to run these packages. Notice I only have the package names here. The reason why is because I'm going to concatenate those with sudo apt get the yes flag and install within a for loop. Okay, now I have an integer variable. It looks like an integer variable. Num equals 0, and I'm going to use that as an increment variable. Okay, but in Python, unlike Java, unlike JavaScript, unlike C++ or C, you cannot, and the language is not designed to increment with plus plus or minus minus. All right. The way you increment variables in Python is you overload the operator with whatever the next operator is, and then give it the operand of however many increments you want. Okay, so whoops, whoa, I am so sorry, viewers. If anybody else besides who this is intended for to view this, I am very sorry. I try to make this informative as possible. So we know where our list 1 is. Our list 1 holds all these packages we need. Okay, we have to have G++, build essentials, and these MPI programs, these MPI libraries to compile MPI code. Okay, so for X in list 1, if num is greater than 4, okay, and we had 5 arguments, if you will remember correctly, 1, 2, 3, 4, 5, and sudo apt-get update at the 0th position, a sudo apt-get upgrade at the 1st position, a distribution upgrade at the 2nd position, this command line argument at the 3rd position, and then a sudo update db at the 4th position. Okay, so if our list, if our increment variable is greater than 4, which would represent our list being at rkhunter, then we are going to concatenate apt in plus that index position of x. So that gives us sudo apt-get y install, the name of the package, and we're going to pass that to the call function as an argument. Okay, so it'll perform that like as if it was a command line statement. All right, and so then if it's less than 4, the else to that is if it's less than 4, it's just going to execute the string that is in the list by itself without the concatenation. Makes sense? Pretty easy, huh? Okay, and so next up, then we're going to create a .sh script that is going to clone. We're going to create a bash script that is going to clone the MPI repository that we're seeking. Okay, and we're going to write that to a file. Of course, this list right here is three strings that are going to be written to a file that we are then going to change the mode of execution on that file. And here is where it is written to the file. Okay, and we're going to change the mode of execution on this MPI get.sh file, and then we are going to execute that file as we're doing here. Here's a string variable to hold these arguments. This is the command line statement, chmod plus x MPI get.sh, and then immediately following that, we're going to execute that MPI get.sh script, and immediately following that, we're going to update our local database. Okay, and that's going to be all like it was like you just typed it at command line. All right, and we're going to pass that, which is all that stored in a string variable called chmd. So we're going to pass chmd to the call function, which is part of the subprocess module, and the call function is going to execute that as if it was like a command. It's going to open up a shell and execute those from command line. Okay, and then once that is done, our MPI directory should be downloaded from GitHub, and we are going to move its contents into our home directory, which on our cloud operating system should be home/Ubuntu is the home directory of the instance creator's user, which in this case would be me, or you can take part in this, would be us, since we're about to do it. All right, and once we execute that, we are then going to execute the quickbench.sh shell script. Okay, the quickbench.sh shell script executes the benchmark C++ executable that is compiled from this benchmark C++ class file. All right, which contains our MPI lines of code and whatnot. All right, so since our instance is now running, I'm going to exit this terminal. I'm getting kind of sloppy here. Since our instance is now running, we are now going to SSH connect to that instance, and hopefully our yes, and I have shmoded this. Hopefully our internet connection will be better on this go round than it was on the last time when I just tried this 25 minutes ago, and I was getting on my cloud server or my cloud operating system. I could not download from the repositories. It was just too slow. So I was afraid there might have been like a security breach or something. I don't know, I was worried something wasn't right. So anyways, I am connecting for the first time to this instance and permanently added that. That is good to the hosts, and we are Houston. We have liftoff. Okay, now I personally set my own prompt here for my cloud operating system. And that's kind of dorky, but I like to do that because I don't like even though it says at the top of my terminal, I don't like looking at it on my prompt, the user IP address or the alias IP address that they give you. this right here, Ubuntu EC2. I don't like that. I don't like looking at that on my prompt. So I'm going to go to nano.bashrc. I love Nano. It is so much better than Vim, in my opinion, because I went for a long time without having any shift keys. And if you try using VI without shift keys, you are going to beat your forehead against a brick wall, I promise you. It is very frustrating, especially when they're like intermediate, they're intermittent, where they'll like work sometimes and then they won't work. So you're just sitting there pressing the shift key, trying to get it to work. It's really aggravating. It is very hard. So I'm going to source the .bashrc file now. Alright, so clear this. Alright, so we are logged in. Uname V. Now we're going to check the kernel version of our cloud operating system. And this is 3.13074. Okay? Alright. Now, I just showed you the script that I think I've perfected. I think I have perfected it. Okay? And I am about to open this up. I am about to move this. Whoa. I'm about to copy and paste from my local machine, from my local hardware where I sit in front of right now. I'm gonna copy and paste the Python script that I've created, and then paste it. I'm gonna copy it from my terminal on my local machine and paste it to the SSH connection terminal of the Ubuntu EC2 user. Okay, and we're going to do that with a combination of cat and nano. I'm gonna cat it first. I like using cat to display scripts because I can copy and paste it and it'll drag down a lot easier in terminal. As you'll see how it drags down? Yes. I don't have to copy it in sections. I'm going to paste this within Nano on our cloud operating system, our cloud instance here. And here we go. Let's make sure all this is right. Alright. I have commas on all of my list positions. That's correct. That is correct. The variable for the file opening function is correct, and it is the indentation is proper on it, and pinch move, and that looks right. All that looks right. Okay, so we're going to close this right now. Okay, so right now we're going to update our local. Oops, daisy. We're going to update our local database here. That needs to be done. And since we are running, and we have a steady, what seems to be a solid SSH connection to this instance, I'm gonna sign out of the Amazon Management Console and just go and close out of Google. Okay. All right. So we know that the name of our file here is this right here because I have created that and I've showed that to you. I'm about to execute this. Let's cross our fingers. Houston, we have liftoff. It's working. Oh, it's working fast. May it continue to work, hopefully. We've got new versions of config files. And this is setting all this up. Stop wait, SSH start running. It has done that. See here, it is, now we're getting our new Linux image. This will be 3.13079, so we are upgrading our kernel. And we're not going to run an email server on right here, so we're going to do no configuration to test that. That's RK Hunter. That's a security. That's a piece of security software. And unhide is very useful too for checking possible promiscuous activities on an operating system. I like to have those around just in case something might happen. Okay, so here we go. It's installing Build Essentials in G++. It's actually letting us, so we know we've done right. If you do not update and upgrade and distribution upgrade, or just update, actually. The update, the initial first update is what, and our quickbench.sh, our quickbench bash script, shell script, is working, and it's currently using 2 processors. That's actually wrong. It's not processes, 2 processors. It's going over 2 cores right now. It's calculating the amount of threads or processes coming across 2 cores, individual cores of the 36 cores. Okay. Now back to what I was saying about the a sources list. If you do not update and upgrade the initially when you get a new installation of Ubuntu, then your sources list won't be upgraded, and the package repository and your package list will not allow you to install Build Essentials or G++, because those don't come with the base packages. Those aren't part of the base package source list. Okay, so those MPI libraries and all that stuff, we had to update our operating system in order to have our sources list updated, and that was another reason why I ran that that command line statement of the exit command piped to the argument trap of $1, which is then piped to bash to open and close that shell real quick for that to take effect. Okay, so I know this looks strange. The totals are all the same. The infinite, yes, they are for the 36 core processors. Now I'm about to show you something here. Okay, as we go up and we go back to 2 processors, the total was, okay, this 0 right here signifies 1,000,000. That's right there is 1,000,000,000. That's 125,750,000 threads or processes across 2 processors, 2 individual cores. Okay. Now, when we go from 2 individual cores, 2 processors, to 8 processors, I know whoever wrote the program did not do that right, did not spell processes right, but logically it would make sense that would be processors. Okay, when you look at this, when the amount of processors used, the amount of cores used, quadruples from 2 to 8, that 125 billion then becomes 7.8 billion processes or threads across 1 core, each individual core. Now that per core is a reduction of 95%. Okay, that has to do with the amount of computing power. So there's less computing. There's less. Excuse me. There's less strain on the 2 processors. When there's 8 processors total, it allows for the system to have more computing power, and in turn, the shared resources make everything more effective. All right. Now, when we go down here to we went from 7.8 billion with, what the frick? We went from 7.8 billion. We went from 7.8 billion to we went from 2 processes, oh my goodness, we went from 2 cores and having 125 billion processors or threads to 8 cores and having 7.8 billion processors or threads, which was a reduction of 95%. Okay, now if we quadruple that was we quadrupled the amount of cores going from 2 to 8. If we quadruple the number of cores going from 8 to 36, we go from 7 0.8 billion threads or processes going across each core to the 36th total of 385 million, which once again is that's a 95% almost a 95% reduction. So we're definitely scaling. There's definitely scalability, and the MPI program measures that scalability. Okay, or the MPI classes or the libraries, I should say, they measure that scalability. Now, if we check out, pull this right here, we cat this benchmark.txt file that was outputted, we will see that 2 processors took 40,894 milliseconds to complete. 4 processors, 4 cores, instead of wherever it sees processes, think cores, okay? Because that's misspelled. That's supposed to be processor. But 4 cores took 10,000 milliseconds. 8 cores took 2,500 milliseconds. 16 cores, 1,300 milliseconds, so on, so on. 36 cores took 452 milliseconds. Okay, that's essentially saying 9 Intel Sandy Bridge i2500Ks with quad cores in them. That's basically 9 individual physical chips that have 4 physical cores in each chip. That's what 36 is. All right, I'm actually going to copy and paste this into from our report that I'm going to write for this, and nano benchmark complete .txt file. Do that right there. Exit yes, yes. And I'm going to move this to my actual home directory, which is home/geo, and then sudo chown that. Alright guys, well, I do believe this is the end of everything. I hope this was informal, or informal. It was informal. I hope it was informative, and I hope you enjoyed it. Sorry if I sounded a little frantic at times, but it's it's kind of a learn as you go, and I had technical problems with like I said, with the software and the mic check, but I figured that out with the settings, and as stated before about the OBS software and Unity, and OBS for some reason using up a ton of my CPU consumption, my CPU resources. Here, running the cloud instance, doing all this stuff with OpenBox and the LXDE desktop environment, I'm using 33%. So that works, and that works too. That's good for me. Alright, so I'm going to exit out of here. I'm going to exit my... Is there anything I want to keep here? Is there anything that I want to keep? No, I think that's it. So I'm going to exit this, and I'm going to now go back and delete my my instance, and I am going to delete this user account and uninstall LXDE. Okay, so I hope y'all have, or whoever sees this, has a great rest of the evening, and don't do anything I wouldn't try at least twice while computing. That's all I gotta say. Goodbye.